Here we have a problem on derivative. There is a function given over here that is y equals to sine x cube, and we have to find dy over dx. That is, we have to find the derivative of this function with respect to x. Okay, let's consider just a basic sine function, that is sine x. What is the derivative of sine x? We already know that the derivative of sine x equals to cosine x. Okay, so what's the difference between the stuff we have over here and the stuff we have in the given function? So here we have just x, the variable x, but here for the same variable x we have the exponent 3. So if it is just sin x, easily we can find its derivative, that is cosine x. But here for the variable we have the exponent 3. So this is a troubling part. So instead of x cube, I just have single variable like something like x. Okay, so now what I'm going to do is to avoid the exponent 3 over here. So I'm going to assign a new variable for this x cube. So that let u equals to x cube. Now, when I assign u for this x cube, then the given function will become what? Then it will become y is equal to sine u. Okay, now we just have single variable over here, and I can find derivative of this one easily. But here, y is a function of u, but my aim is to get derivative of y with respect to x. So here I cannot find the derivative of this function with respect to x because y is not a function of x, y is a function of u. And moreover, we have u equals to x cube, that is u is a function of x. So y is a function of u and u is a function of x. So I can use chain rule to get the derivative dy over dx. So let me find derivative of this y with respect to x, that is dy over dx. But here, according to the function we have over here, I cannot find the derivative of y with respect to x immediately because y is a function of u. So first, let me write the derivative of y with respect to u because y is a function of u. So I get derivative of y with respect to u times, now u is the function of x. So I can get derivative of this u with respect to x. Then I can write this one as du over dx. Okay, now to get dy over dx, first I find derivative of this y with respect to u, and then I get derivative of this u with respect to x. So I start from dy in numerator of the first fraction, end with dx in the denominator of the second fraction. So the product of these two derivatives are equals to dy over dx. Okay, now dy over dx equals to d. So for this y, we can plug in this sine u. So sine u over du times d of, and for this u, we can plug in x cube. So d of x cube over dx. So now dy over dx equals to, already we know that what is the derivative of sine u with respect to u. So here we have discussed the derivative of sine x with respect to x is just cosine x. Then what is the derivative of sine u with respect to u? It's just cosine u times. So to get the derivative of this x cube with respect to x, I have to use the power law of derivative. That is, I have to bring this exponent in front of the variable and subtract 1 from the exponent. Then I'm getting 3x square. So dy over dx equals to, so we can write this 3x square in front of this cosine. Then I'm getting 3x square times cosine u. So actually u is the variable taken by us. So to make the derivative process easier, I just assumed u for this x cube. So we should not give our final answer in terms of the variable which has been taken by us. So it has to be replaced. I mean, u has to be replaced by the original stuff, that is x cube. Okay, let me do it. So dy over dx equals to 3x square times cosine. So for this u, we can plug in x cube. So now I got the derivative of sine of x cube, the derivative of sine of x cube with respect to x, that is dy over dx equals to 3x square times cosine of x cube.